The multimeter allows several measurements to be taken. We can measure voltages. We then call this device voltmeter, since the unit of voltage is the volt. It can measure current intensities when it is an ampermeter. It can measure resistances. It is always used with two connection wires. One of the two wires is always placed on the COM terminal because it is the common terminal. The question will arise for the other connection wire. If we want to measure voltages, then there is a wire on the COM terminal. It always will be. The other wire will be on the connection terminal noted VV as volts. We learned here that the voltage measured at the terminals of the bulb, between these 2 points, is around 4 volts. You notice that the voltmeter is mounted in parallel, between 2 points. To have a more precise measurement, I can go down to 200 volts. I specify 200 volts because the ranges have a unit. We don't say the 200 range, we say the 200 volts range, which measures up to 200 volts. We can even go to 20 volts, since we can measure with this range up to 20 volts. So we can read 4.27. Can we go to 2 volts to measure this voltage? Certainly not. We avoid doing it. There, we can do it because we are in the virtual world. So what happens if I go there? Well, the screen tells me there is an error. So I must not stay in this position. We can measure alternating voltages, such as the mains voltage, for example, or the voltage across a transformer like here. You can use the multimeter as an ammeter. So here is the black plug, still on the COM terminal. That's invariable. The other wire, I put it here on the milliamperes terminal. And I chose the range that only measures up to 2 milliamps. Is this really a good idea? So, for now, I haven't closed the switch yet. I did not say that the ammeter was mounted in series. It is important to know that the same current flows through the ammeter as the following dipole. So here if I close here, the current would go from the positive terminal to the negative terminal. It would cross the ammeter before crossing the bulb in series. The precautionary principle tells me that is not a good idea. And I would perhaps put, and you will see that it is the case, my device in danger. I first chose the larger range. That is to say 10 amps. If I put myself on 10 amps, well, the other wire must go, naturally, on the terminal 10 amps. There I can safely close the switch. 10 amps is a lot. So a range that measures 10 amps isn't a big deal. In fact, I'm reading something around 0.18 amps, which is around 180 milliamps. So I can afford to go on 200 milliamps. By changing the terminal, this time, I put it on milliamperes, and, by closing the switch, I realize, indeed, that I have 184.7 milliamperes. I cannot be more precise because I already said 2 milliamperes, here, is prohibited. You must not go there. If I go, it is very serious. The ammeter, it is marked here, could be damaged. So, since it's virtual, I'm going. But it must not be done. We can measure resistances by putting on 2 megaohms or 200 kiloohms, 20 kiloohms. The screen showed 0 because I was on very large ranges. I can go on 2 kiloohms, i.e. up to 2000 ohms, 2 kilo equals 2000. And I read that it is about 0.039 kiloohm. What is on the screen is what is displayed at the same unit as the range. So since the range is kiloohms, what I have on the screen are kiloohms. So I can go over 200 at that point, 200 ohm. What I have on the screen is in ohms. This resistance is 39 ohm. The resistance is not connected to anything else when it is measured. I could also evaluate it with the color code. That's it for this video. Thank you.